Okay, so um, this is the slide on net energy where there are losses during the production and the use of, like on the solar panels. So sunlight is absorbed into the solar cells, and a big part of energy that is lost is through heat. And then we can break it down into wavelengths, recombination, temperature, and reflection. So basically, when we're just talking about wavelengths, we're saying that there's the different types of wavelengths through ultraviolet and infrared, and when they strike the surface of the solar cell, the photons are reflected, and then other photons pass right through it. So the ones that are absorbed have their energy turned into heat, which can become a loss. And the remainder is the energy that's separated into electrons, and they can produce an electrical current, which is also a loss in the production. And then recombination, this is when an electron encounters a hole, and they like cancel out their contributions. And then basically what happens is that the factors are limited, and indirect recombination is also a problem with losses because the holes like might be defective, and it will like mess up the structure and then like make it so that their energy is released as heat because the structure can't get through the solar panels. And then after that, there's temperature. This is really self-explanatory. Higher temperatures can cause problems with the solar panels themselves, and also how the solar panels collect the energy through the photons, because they're already releasing a large amount of heat through losses, and if it's at a high energy, then that heat is just burning off. And then finally we have reflection, and this is the light reflected off of the solar panels, so it's not being absorbed by the solar panels. So silicon reflects more, and so if you have a lot of coatings or textured surfaces, this will help decrease the reflection and therefore decrease the amount of losses that is occurring. And then we have a quote from a source from the government that says when sunlight is absorbed in a solar cell, negatively charged electrons and positively charged holes are created, which in turn drive electrical current producing power. The absorbed light produces electrons and holes with a range of energies. Those with larger energy, called hot electrons and holes, tend to lose their energy in the form of heat before it can be converted into electrical current. So overall, these are just types of way that heat can be lost, but it's heat. Heat is what is lost. So next we have water use during each stage. So in general, solar panels really don't use a lot of water, approximately 20 gallons per megawatt hour. And this is mainly for cleaning the solar panels so that they're better able to take in those photons and not lose as much. On a solar farm in the Central Valley, the company said that the project will likely produce 106,000 megawatt hours of power each year, and using about 0.2 acre feet or around 65,200 gallons to clean the panels. That works out to a very thrifty 2/3 cup of water per megawatt hour. So this just shows how little water is actually used in the stages of the solar panels when they're actually producing energy through the sunlight. But we do have to take into account that while it doesn't use a lot of water to actually be in production, there's a lot of water used to create the solar panels. And someone described this saying, the semiconductor manufacturing requires massive amounts of water. Just a 2-foot wide wafer of semiconductors consumes 404,000 gallons of water. Solar power systems require hundreds of square feet of semiconductors. So if we think about that, that's only 4 of the little squares of a solar panel that uses that much water to be produced. Which is really problematic because while they might not use a lot for actual production, they use a lot for the creation of solar panels. So these are some graphs that go with the water consumption. So on the left-hand side, it's effects of unmanaged and managed water heating and solar PV on net load. So this is really interesting about specifically looking about how much water is used and the solar generation compared to the water amount. And then on the right hand side there is an infographic which was super popular and going around in the climate sphere of media that says it shows how little solar uses in production, but what it does discount is the amount of water used in the making of solar panels. So after that, we have impacts on social justice communities during each stage. So there's been a wide variety of responses to solar panels and solar energy from social justice movements. There was a great study done in the UK where scientists went around and interviewed almost 400 citizens who had solar panels on their houses and asked them a variety of questions about who was involved in the decision making of getting solar panels. They found that the theme of gender relations and primarily male decision-making came up repeatedly within our sample, with multiple interviewees suggesting that decisions about solar and energy adoption were made by men with little to no input or even awareness or understanding on behalf of women. This does show a big gender gap in terms of the solar energy sphere and the knowledge regarding how everything works, which could be problematic in social justice communities. There's also discussion about worsening demographic inequalities and unfair adoption of patterns within social groups. This is due to the expensive cost of installing solar panels for family units and also the cost of buying affordable electricity from solar farms and whatnot, which can really widen the wealth and inequality gap. So proponents do say that solar energy is a clean and renewable way to power our world because it doesn't release more carbon pollutants into the atmosphere. It's a win-win, good for our climate, good for our health. So there are, of course, proponents because it's great for the environment, but there are major drawbacks in our social realm because of the gender gap and the inequalities of economic statuses. This is just the data found in the UK research, which shows how much more males, especially older retired males, took initiative with solar and how females were not able to have input. So for our last slide, we have non-renewable resources required by the technology. So once solar panels are in action, they're completely renewable. The sun is used as a source, which cannot be depleted. But the question comes in when we look at the production of making solar panels, and in some defense, it shows that most solar panels produce electricity for 25 years or more because the parts don't wear out easily. In fact, many of the solar systems installed over 40 years ago are still active today. So they're super, they last a long time, they don't use non-renewable sources, but in the making of solar panels, solar panels are manufactured in factories that are often reliant on non-renewable powers like coal. But a company located near Silicon Valley has a solution stating, our goal is to replace all petroleum plastic out of solar cells and with bio-based ones, which will help hopefully decrease the non-renewable resources required for solar panels to zero. Thank you.